Hello guys, in this lesson we're going to be solving some of the questions we are given as a take home in our previous lesson on empirical and molecular formula. In our previous lesson we were given a couple of questions, about 3 questions to test how much we got from that very lesson. So this very question was the first question. Now we're given this, the analysis of a compound gave this. 1.25 gram of the compound contains 0.62 gram of potassium. 2.51 gram of the same compound contains 0.51 gram of sulfur. 1.87 gram of the compound contains 0.57 gram of oxygen. Solve for the empirical and molecular formula. If its RMM, that is relative molecular mass, is 158. Now the first thing we're going to do is to write out the parameters. Let's write out all the things we're given. We're going to state it out there, just out here. So first, 1.25 gram of the very compound, 1.25 gram of comp contains what? Contains 0.62 gram, 0.62 gram of potassium, represented by kalium. The next have 2.54 gram of the same compound, the same comp, this is a short form, contains 0.51 gram of sulfur, 0.51 gram of sulfur. So 1.87 gram, lastly, of the same compound contains 0.57 gram of oxygen. Now, and also we are given our relative molecular mass as 158. So we have all what we need stated out here. We're going to use all this to solve for empirical and molecular formula. So the first thing we're going to do is to get the percentage composition of each of these elements in different samples of this compound. 1.25 gram of this compound. Don't forget, 1.25 gram, 2.51 gram, 1.87 gram of the same compound. The compound has not changed. That is where the law of definite proportion or constant composition comes in. Regardless of the samples of the compound or the method used in producing each of those samples of that very compound that contain the same proportion of elements that make them up. So 1.25 gram of this compound contains 0.62 gram of potassium. So what's the percentage of potassium in this very compound? So what are we going to do? We're going to be using our calculator to get the percentage composition of each of these elements. So first of all, for potassium, we have 0.62 gram of potassium out of 1.25 gram of the sample of the compound times 100 over 1. So let's say the percentage of potassium in this very compound. So you're going to be using this, let's use a calculator, 0.62 times 100 divided by 1.25. That will give us 49.6%. 49.6% is the same thing as 50% approximately. Let's use that. So the next we have is on sulfur. Sulfur is the next element. We have 0.51 gram of sulfur from 2.51 gram of the compound. So 0.51 gram of sulfur over 2.51 gram of the compound times 100 over 1. So let's see that 0.51 times 100 divided by 2.51 gram of the very compound. That will give us 20.3%. We have 20.3%, which is 20.3%, approximately 20%. So the last we have is oxygen. Let's say the percent composition of oxygen. We have 0.57 gram of oxygen out of 1.87 gram of the compound. 0.57 gram of oxygen out of 1.87 gram of the compound times 100 over 1. So let's see that is 0.57 times 100 divided by 1.87. That's 30.4%. 30.4%, which you can assume to be 30%. So right here we've gotten all the percentage composition of each of this element in this very compound. So we're going to progress right now to using the tabular method to get our empirical formula. So you know that we're going to be getting the mole for each of them. So first, potassium stays here. In sulfur, oxygen. So for potassium is 50%, for sulfur is 20%, for this is 30% oxygen. So what's the atomic mass of potassium? Potassium number 19 on the periodic table has 39. Then sulfur is 32, number 16 on the periodic table. Oxygen is 16, number 8 on the periodic table. So we're going to get the mole for each of them. So 50 divided by 39 will give us 1.28. 1.28, let's say 1.3 to 1 decimal place. Then 20 divided by 32 is 0.625. So that's going to be, let's say, 0.6 approximately to 1 decimal place. And 30 divided by 16 will give us 1.875, which is same thing as 1.9 approximately. So we're going to use the least of all of them. We're going to use the least to divide all through. So what's the least? 0.6 is smaller than the other two. So that will be 0.6 divides all through. So this is 1. So 1.3 divided by 0.6. 1.3 divided by 0.6 will give us 2.1. This is 2. That's 2. This 1. Then 1.9 divided by 0.6 will give us 3. So what do we have? We have K2S1O3. So that's K2SO3. That's what we have. This is our empirical formula. So how do we get our molecular formula? Now we're going to get our molecular formula by using an imaginary number of atoms to multiply this. So when we use our imaginary number of atoms to multiply this, we're going to get the relative molecular mass for our molecular formula. So let's get that done right away. Let's do that right away. Take control of this first. So right here we have our K2SO3. So right in here, K2SO3, multiply this by an imaginary number of atoms, which will give us our relative molecular mass for our molecular formula. We've been given already 158. Already 158. So don't forget potassium has an atomic mass of 39, sulfur is 32, oxygen is 16. So 2 atoms of potassium, 2 times 39, plus 1 atom of sulfur, 1 times 32, plus 3 atoms of oxygen, 3 times 16, times n equal to 158. So 2 times 39 is 78, plus 1 times 32 is 32, 3 times 16 is 48, times n equal to 158. 78 plus 32, what would that give to us? That will give us 110. 110 plus 48 will give us 158 n equal to 158. Divide both sides by 158. So n is number of atoms is 1. So when we use the 1 to multiply this, K2SO3 times 1, you see give us K2SO3. So we have the same molecular formula as the empirical formula. As easy as that. Okay, let's quickly solve the second question. We're given the second question. Let's quickly deal with it. Now, sulfur X in 0.520 gram of nickel sulfate with some air and crystals of water. After strong heating, left 0.304 gram of residue. Nickel has an atomic mass of 19, sulfur is 32, oxygen 16, H, which is hydrogen, is 1. So we're asked to get the amount of water crystal. That's the value of X here. That's what it is. So how much water was left? Was it 5 molecules? Was it 10? Let's get a C. So we're going to be using empirical formula approach to solve this. And also we can use the other method to solve this. So quickly, the main start is 0.520 gram of this compound, NiSO4 nickel sulfate S crystals of water. So after it was being really heated, we are left with 0.304 gram of residue. We are left with 0.304 gram of the NiSO4. So some water left. So let's see the amount of water left. So the amount of water that was left or that evaporated after heating is simply this. Let's do our math. 0 minus 4 is not possible. Yeah, 6. This 1. This 2. 0.26 gram of XH2O was lost. So we're going to work in with this 2. We're going to work with this and this. So first of all, NiSO4 right here alongside an SH2O on this side. So what do we have? The nickel sulfate 0.304 gram. The iron water H2O is 0.216 as stated. So it's time for us to get our mole. So this mole is, don't forget, is mass over the molecular mass of the compound you're dealing with. So you're going to get the molecular mass, NiSO4, let's quickly do that math. NiSO4, nickel itself is 59, you have just one atom of it, plus sulfur, one atom, times 32, 4 atoms of oxygen, 4 times 16, that's 59 plus 32 plus 64, so 59 plus 32 will give us 91, 91 plus 64 will give us 155. So right here is 155, then over, so that's a 155 gram per mole. I think you're right with that. This 96. This 96. This 155. That's correct. So for water, 2 atoms of water, 2 times 1 is 2 plus 16 is 18. Water is 18. As simple as that. So let's use our calculator to get the mole for each of them. Let's get the mole. 0.304 divided by 155. That will give us 0.00196. So 196 like this. You know, this is to 5 decimal places. And then 0.216 divided by 18, 0.012, 0.012. So we have the set already. So we're going to use the least. Which of them is smaller? We're going to use the lesser one. This is smaller than this. 0.00, 0.01. So use this to divide all through. 0.00196, 0.00196. This takes out this. We have one left. Then 0.012 divided by 0.00196. That'll give us 6. So 6 point something, approximately 6. So what do we have? What we have here is we have NiSO4 and 6 crystals of water. So the X is 6. As easy as that. It's very simple. Okay, now we have another method we can use, which is the alternative method. So how do we go about using the alternative method? Now we're going to be using what we call the percentage composition, or rather the mass composition is around, we don't need percentage. So since we know the mass of this water that got evaporated, we know it to be 0.216 gram, and we know the mass, the general mass of this, NiSO4 S2SH2O. So we're going to get the general related molecular mass of all this, and also the related molecular mass of just the SH2O. So very simple. We've done that in part here. We've done that in part here. So RMM of NiSO4 SH2O. The NiSO4 that we got 155 gram. That is 155 plus H2O is 18. 155 plus 18x is the absolute work. This is a absolute related molecular mass of this very compound. So why that of water? Water only is 18x itself. So what do we do? Don't forget the mass composition. What we are looking for this, the molecule of this. So it's going to be this over all this. So that will be 18x over 155 plus 18x equals to, what's the mass of SH2O? 0.216 gram. What's the mass of general mass of the whole thing? 0.520. gram. So what do we have? 18x over 155 plus 18x equals to, so we're going to use our calculator to get this done, 0.216 divided by 0.520. I'll give us 0.415, let's say 0.42 approximately. So from here we cross, multiply from here, let's get to this other side. We cross from here, cross multiply, across multiply from here. So we're going to have 18x times 1, which is 18x, equals to 0.42 times 155 plus 18x in brackets. So 18x equals to 0.42 times 155. 0.42 times 155 will give us 65.1. Then plus 0.42 times 18x. 0.42 times 18 will give us 7.56. 7.56x. So collect our likeness to send this over to this side. 18x minus 7.56x equal to 65.1. 65.1. So 18x minus 7.56, that will give us, just quickly use this to save our time, minus 7.56, 10.44, 10.44x equal to 65.1. Divide both sides by 10.44, 10.44. The x is 65.1 divided by 10.44, 6.2, which is approximately 6. It's still the same result, as simple as ABC. Okay guys, here was the last question we were given as a take-home in our previous lesson. An organic compound with a molar mass of 126 grams per mole contains carbon, hydrogen, oxygen, and sulfur. On analysis, 1.5 gram of this very compound produced 2.8 gram, 0.63 gram, and 1.1 gram of barium sulfate, water, and carbon dioxide respectively. Now solve for the percentage composition of each element that makes up this very compound, and also solve for the empirical and molecular formula. Barium is 137, hydrogen is 1, oxygen is 16, sulfur is 32, carbon is 12. It's very simple. We've been given all the things you're going to work on. So first of all, you're working on 1.5 gram of this very compound, just a portion of it. So 1.5 gram of the comp. Don't forget that the comp is made up of, the compound is made up of carbon, hydrogen, oxygen, and sulfur. So these are the things you're going to stay focused on. You're working on just these four. These are the major elements, the major players. So just 1.5 gram of the compound contains this. So on analysis, we got, what did we get on analysis? On analysis, we got 2.8 gram of barium sulfate, BaSO4. And after that, we got 0.63 gram of water, H2O. And after that, we got 1.1 gram of carbon dioxide, CO2. These are the things we got after analyzing 1.5 gram, of this compound that contains carbon, hydrogen, oxygen, and sulfur. We got all this. So the analysis maybe it was burned in oxygen or something, but we got all this. These where the materials got it, the product, the compounds got it. So from all this, we're going to be analyzing. We're going to be bringing out the mass of carbon, hydrogen, oxygen, and sulfur that makes up this 1.5 gram of this very compound. So also don't forget we're given the RMM, the related molecular mass of this 126 gram per mole. Very important. So we have everything stated out already. So first of all, barium sulfate. Let's work on barium sulfate. BaSO4. So we're going to get the relative molecular mass of BaSO4. So barium, one atom of it, 1 times. Barium mass 137 gram atomic mass unit. So plus sulfur 1 times 32. Oxygen is 4 times 16. So altogether, there's 137 gram of barium plus 32 gram of sulfur plus 64 gram of oxygen. So altogether, when we add them, this will give us 96. 96 plus this, it gives us 233 gram per mole of barium sulfate. That's what we have, 233 gram per mole of barium sulfate. So don't forget, what are we working on? We are working on mainly on carbon, hydrogen, oxygen, and sulfur. So let's see if one of them is here. We have sulfur right here. So it's only sulfur we're going to fixate on. We're going to focus on sulfur. So let's see, sulfur. What's the mass of, let's see what sulfur is going to be towards sulfur we are looking for. So don't forget that 233 gram of BaSO4 produces 32 gram of sulfur naturally. That's a natural phenomenon. Then, what do we have? 2.8 gram of barium sulfate, 2.8 gram of BaSO4 to produce how many gram of sulfur? Let's see. So we're going to use our calculator. 233 x equals to 2.8 times 32. So divide both sides by 233, 233 like this. So what do we have? 2.8 times 32 divided by 2.8 times 32 divided by 233 is 0.38. So we have 0.38 gram of sulfur. So right here, you write it down, 0.38 gram of sulfur. That's what we have out of the very chemical compound. So the next thing now we're going to be solving for that of the other element, which is hydrogen. I'll give the next one in line. 0.63 gram of water we produce the answer to that. So let's work on that. Let's work on that quickly. Let's work on that. So we have 0.63 gram of water, 0.63 gram of H2O. Naturally, water was a relative molecular mass of water. Water is 18 gram. 1 times 2 plus 16. 18 gram of H2O contains 2 gram of the H2 and 16 gram of the oxygen. So we'll just focus on this. 18 gram of water now produces 2 gram of hydrogen. Then 0.63 gram of water, 0.63 gram of water will produce S gram of hydrogen. You cross multiply 18 times S is 18x, 0.63 times 2. So divide both sides by A word by 18. What do we have? 0.63 times 2 divided by 18 will give us 0.07, 0.007 gram of hydrogen gas. So hydrogen here is 0.07 gram. So we're going to get now the mass of carbon. Carbon is the next one in line. So here we have 1.1 gram of carbon dioxide. Let's quickly get that done. It's time to work on carbon. It's time to work on carbon. So right here, 1.1 gram of carbon dioxide, 1.1 gram of CO2. So what does that mean? What does CO2 itself mean? What's the relative molecular mass of CO2 naturally? CO2, this one atom of carbon, 12 plus 16 times 32. So 44 gram of CO2 contains 12 gram of carbon and 32 gram of oxygen. So don't forget, right now we are looking at carbon. Carbon is the next one we are looking at. So if 44 gram of CO2 contains 12 gram of carbon, then 1.1 gram of CO2 will contain how many gram of carbon? X gram of carbon. So we cross multiply. This is 44x up to 1.1 times 12 both side by 44. When you solve this, you end up with 0.3 gram of carbon. So carbon is 0.3 gram. That's why we have to take this down, 440 and 0.3 gram. So we've gotten 3 out of the 4 major elements that we need that makes up the very compound. So we have one more element left, which is oxygen. So we're going to be combining the ones we've gotten before. Then we take it off the general mass of the compound. So let's solve that. So don't forget that the compound itself is 1.5 gram. And right here we have 0.3 gram of carbon, 0.07 gram of hydrogen, 0.38 gram of sulfur. So what's going to be the mass of oxygen? That's the next. So you're going to get the mass of oxygen right now. What do we do? 1.5. Let's use our calculator to subtract all this. We add all the others together and take it off 1.5. So 0.07 plus 0.38, then plus 0.3. What do we have? It means the oxygen is 0.75 gram. As simple as that. So now we have everything stated out. We have all the constituents of the compound. So the next thing I'm going to do is to get the percentage composition of each of them. Now we're going to use this percentage composition to solve our empirical formula. So quickly, let's take off what we have here and quickly solve up. Okay, so what do we have? So carbon first. Carbon is going to be here, right here. After carbon, we have hydrogen. After that, we have oxygen, and after that, we have our sulfur, just like this. Now, out of 1.5 gram, we have how many gram of carbon? Out of 1.5 gram, we have 0.3 gram of carbon. So what's the percentage of that? That should be about 20%. So out of this 0.3, out of 1.5 that we're talking about, times 100, 20%, very spot on. Then hydrogen, what do we have? Hydrogen, we have 0.7 gram of hydrogen. 0.7 gram of hydrogen. So out of 1.5 gram, 0.07 times 100 over 1.5. What percent of hydrogen is that? 4.66%. 4.666, that's 4.7% approximately. Then the oxygen, we have 0.75 gram of oxygen. So out of 1.5 gram, what do we have? We have 50% of oxygen. We have excess oxygen in this whole setup. Then sulfur, which is the last one, 0.38 gram of sulfur, 0.38 gram of sulfur, 0.38 gram of sulfur. Then out of 1.5 gram of sulfur, what do we have? We have 25.33 and so on percent of sulfur. So right here we have all the percentage composition. So we have more oxygen in this than any other word element. So now what we're going to do next is we're going to use a least to divide out to. The least here is 4.7. Before we even do that, I beg your pardon. The next thing we're going to do now is to get the mole. Let's get the mole. Carbon is 12. Divide out through. Hydrogen is 1. Oxygen is 16. Sulfur is 32. So forget that each of those percent, they are more or less like the mass now that we're talking about. So 20 over 12, quickly, let's do the maths again. 20 over 12 is 1.666, is 1.67. 1 divided 4.7 is 4.7. 50 divided by 60 by 16 give us 3.125, 3.2, whichever. 25.3 divided by 32. Let's see what we're going to get from there. 0.79. So now which of them is the least? The least among all of them. Now we can see the least 1.67, 4.7, 3.125, 0.79. For the oxygen 16, 32, 1, everything is spot on. So the least among them is 0.79. It's going to divide all three. 0.79, 0.79, 0.79, 0.79. So you're going to divide 1.67 over 0.79. Let's use our calculator to do that. 1.67 divided by 0.79. That will give us 2.11. 2.11. Then what do we have next? What we have next, 4.7 divided by 0.79 will give us 5.9. That's 5.9. This 2. Okay, this 2.11 more or less like 2.1. This 5.9. y 3.125, 3.125 divided by 0.79 give us 3.95. That just gives us 1. So what do we do here? The next thing we're going to do now, we're going to approximate. Don't forget we got the mole first. We got the mole of each of them, and then we use the least mole to divide all through. So we have 2.1, 5.9, 3.9, and then so if we approximate, this is 2, this is 6, this is 4, this is 1. So what do we have? The C2H6O4S1. So C2H6O4S. This is the this is an empirical formula. Just as simple as that. This empirical formula C2H6O4S1. So for us to get our molecular formula, we're going to bring all this together and multiply them by a given unknown number of atoms. So C2H6O4S times N equals to, what do we have? This 126 right up there. So let's do the mass. 2 atoms of carbon times 2 times 12 plus 6 atoms of hydrogen 6 times 1. 4 atoms of oxygen 4 times 16. 1 atom of sulfur 1 times 32. All in brackets times number of moles. Number of atoms times the power to 126. This 24. This 6. This is 4. This 32 all together, and equals to 126. So what do we have? 24 plus this is 30. 30 plus this is 30 plus this is 94. 94 plus this is 126, and equals to 126. The variable side n is 1. The number of atoms is 1. So we just add it to the front, just connect it. C2H6O4 times 1, which is C2H6O4. So we have the same molecular formula as the empirical formula. So this everything. So it means if you're able to solve all this from 1 to 3, it means you understood all we took in the previous lesson, and you're a pro when it comes to solving empirical and molecular formula. Now, at this very point in time, we're drawing the content of today's lesson. If you found this lesson resourceful, please subscribe to this very channel at Edu Mosaic. Also follow me on Facebook at Revelation Up, and please share this lesson with others. See you in the next lesson. Thanks.